Welcome everybody to this very special session honoring Mario Roederer and his many achievements. Before we start, just a quick introduction of who we are and why Kathy and I are actually up here today. So Kathy Foulds is a staff scientist in Mario Roederer's lab and chief of the non-human primate immunogenicity core at the Vaccine Research Center of the NIH. She earned her PhD from the University of Pennsylvania and completed her postdoctoral training in Bob Sito's lab at the VRC. In her current role, she advises on the design of non-human primate studies to evaluate vaccine safety and immunogenicity, oversees a team conducting sample processing and flow cytometry-based assays, and contributes to regulatory filings.
So Yolanda Mahnke is a flow cytometry expert with a strong background in immunology and clinical trials. She earned her PhD from the Open University for work at the German Cancer Research Center and advanced her expertise at the Ludwig Institute, NIH's Vaccine Research Center, and Mario Roederer's lab in the University of Pennsylvania. A pioneer in multi-parameter panel optimization, she co-founded the OMIT platform and received ISAC's Mary Lou Ingram Scholarship in 2014. She now leads Flow Know-How, LLC, and is Senior Associate Editor of Cytometry Part A.
We both have known Mario for about 20 years and have worked with him for many of those. So today, it is our absolute pleasure, if we could have the first slide, please, to be chairing this special session in honor of Mario and his very fruitful career at the NIH. Mario obtained his bachelor in chemistry from Harvey Mudd College, which he followed up with a PhD in biological sciences in the lab of Dr. Robert Murphy at Carnegie Mellon University. He then spent 11 years in the lab of Dr. Leonard Herzenberg at Stanford University before joining the University of California in San Francisco as adjunct associate professor in the Department of Stomatology. Shortly thereafter, he was recruited to the newly inaugurated Vaccine Research Center of the NIH, where he created and led not one, not two, but 3 groups. To this day, he continues to be the chief of the ImmunoTechnology section, director of the Flow Cytometry Core, and director of the Non-Human Primate Immunogenicity Core. Whether nature or nurture, it is clear that a curious mind, a penchant for scientific discovery, and an entrepreneurial spirit runs in the family. Mario's father, Juan Roederer, is professor emeritus in physics at the University of Alaska in Fairbanks, where he delved into topics such as space physics, psychoacoustics, science policy, and information theory, while his son Alex is an application scientist and business development lead at Cellular Engineering Technologies, and also the founder and vice president of Thielsen Capital. One can surely imagine some interesting discussions happening around the Roederer breakfast table over the decades. To say that Mario's contributions to science and engineering has been impactful is a gross understatement. He in no small measure helped us advance from a flow cytometer that filled an entire room and could measure but 3 parameters, only one of those was a fluorescence, to desktop instruments handling 50 fluorescent parameters, incessantly pushing the field forwards and inspiring manufacturers to evolve the machinery, reagents, and software. For his many contributions in the field of flow cytometry, Mario received the ISAC Membership Award in 2015. You will probably be aware of some of his work, but not of the incredible diversity of fields he has influenced. One only has to look at the diversity of patents issued in his name to appreciate that Mario is no one-trick pony. And among all these inventions, there's one that most of you will have used at one point or another, the APC-Cy7 tandem dye. Given this cyto setting, it's fitting to highlight some of Mario's key contributions to the field of flow cytometry. But before I do so, I think it's important to point out that Mario did not pursue flow cytometry for the sake of flow cytometry. Rather, he's a deeply creative scientist who believes in creating the tools he needs to advance the science that he is interested in. Mario pioneered multiplexing in flow cytometry, introducing dyes like PE-Cy7 and APC-Cy7, and evaluating the potential of PE-APC, also testing cutting-edge fluorochromes such as Q-dots and BV dyes. He worked closely with instrument developers, contributing to the evolution of high-parameter platforms, and tested new cytometry technologies, such as the CyTOF. Committed to data quality, Mario championed rigorous instrument setup in QC, standardization, biosafety procedures, and panel design, efforts that led to numerous publications, as well as the creation of OMIPS and Cytometry Part A. Mario was instrumental in advancing flow cytometry data analysis. He published early work on autofluorescence correction and introduced two-way spillover correction, a key step toward modern compensation. As a co-founder of FlowJo, he helped transform data analysis with intuitive tools and innovations such as the logical scale, M/M plots, concatenation plots, and the spillover spreading matrix. Those that worked in his lab could literally observe how FlowJo learned new tricks. It was quite something. He also developed the Pestle and Spice software suite, enabling powerful visualization and statistical analysis beyond initial gating. And Mario also initiated and co-organized the highly successful series of 5 Marzier conferences dedicated to the measurement of antigen-specific immune responses, which are still fondly remembered by attendees today. Throughout Mario's career, education was always an important element, and he enjoyed communicating flow cytometry concepts, whether to advanced users or absolute novices. Thus, when then President of the United States, Barack Obama, visited the VRC, Mario gave him a crash course in flow cytometry. Later, cytometrists who attended the president's address to the NIH, or those that watched it afterwards, were pleased to hear the student correctly name the technology, though it remained unclear whether he fully grasped the nuances of spillover spreading correction. Over the past few weeks, Kathy and I communicated with most that actually came through Mario's lab over the last several years. There was a resounding feeling of gratitude for sharing his infectious passion for all things flow cytometry, the pursuit of excellence in science in general, and exceptional attention to detail. Effective communication, whether visual, in written or spoken word, was a top priority, as the best data can go unnoticed if poorly presented. Let us now hear from others that have worked closely with Mario over the years.
Okay, it's my pleasure to introduce my former colleague, Pratip Chattopadhyay. Pratip is a Johns Hopkins trained researcher who completed his NIH postdoctoral training in Mario Roederer's lab at the Vaccine Research Center. He is the former founding director of NYU's Precision Immunology Laboratory and currently leads 2 startups, Talon Biomarkers and terraFlow. Pratip is an internationally recognized expert in polychromatic flow cytometry, immunoassays, and single-cell technologies. He is also a respected educator, former ISAC scholar, and council member.
Thank you guys so much. Thank you, Yolanda, for an incredible introduction. And my talk is going to be pretty personal, and it's going to be uncharacteristic for the way that we did work in Mario's lab. We always had our sort of feet firmly planted in the data and the science. And so this is going to be kind of an unusual talk about the motivations and the personalities and what I learned from Mario. I will start with a funny story because Yolanda showed the picture of President Obama coming to the VRC, and there we had kind of a pecking order of who got to give the demonstrations. And so Mario got the president, Steve Perfetto, and Mario got Cameron Diaz, who is a beautiful actress, and I was left with the scraps, which was the Indian foreign minister for science and technology development. And so, so the title of my talk is The Brightest Light in Flow Cytometry in My Career, a tribute to Mario Roederer. And, oops, going the wrong way. Okay, tributes, especially for your heroes, are pretty hard. How do you celebrate the mentor who is responsible for your greatest scientific memories, taught you leadership lessons that you still lean on every day, and never seemed like a big fan of self-promotion, and has accomplished so much? So Yolanda talked a little bit about what Mario's accomplished, but really, when we start to parse it out, it's staggering. There have been nearly 900 papers, nearly 80,000 citations of those papers. His H-index is 139, and that places him among the top 160 immunologists worldwide, according to research.com, which I just found a couple of days ago. So in the last 20 years, his production has been amazing. He's been a prolific scientist with no fewer than 20 papers every year, except for 2020, when he was a total slacker and started leading translational models in the translational model group for assessing the pandemic response and developing the COVID vaccine that we all took. And so he had a dip below 20 papers that year. But it's really staggering what he's accomplished, and those accomplishments, as Yolanda pointed out, may be genetic. The original gangster, Dr. Mario Roederer, his dad, the OG in the middle of this picture, was the one who first published in Science, and then in 2010, Mario had a publication in Science, and recently, Mario's son, Alex, graduated from Harvard with a degree in virology and also published in Science as well. And so, for those of us who can't keep up with this kind of production and this kind of scientific expertise, we can rest assured that it's probably just that there were incredible genetics here. But the breadth and impact of Mario's work is really quite remarkable. And so I made a series of word clouds from Mario's Google Scholar citations. And the breadth is the word cloud on the left. It covers the topics that are in the titles of his papers. And it's quite remarkable because it's not just flow cytometry, even though that's what we think about at this conference. It's also animal models for disease. It's vaccinology, SARS-CoV work, BCG, TB, malaria, immuno-oncology, and hematology oncology. And the breadth of that work is incredible. The influence that he has had on basic immunology in these settings and the application of technologies in these settings is quite remarkable and inspirational for all of us who stand here. The impact of the work is also remarkable. If you look at the word cloud on the right, you can see that he's published in high-impact journals pretty much constantly: Nature, Science, Blood, and our beloved Cytometry Part A. So why the heck did this guy, who was destined to incredibly prolific scientific career, hire an idiot like me? I had 0 publications from my PhD, and when I came to the lab, I was independently motivated. I believed in the science and was excited about science, and somehow Mario could see that. And so later on, when he was talking about the people that his mentors took on, Len and Lee Hersenberg, he said that they had a history taking on lost souls, and I was a bit of one in a lot of ways because I felt anonymous in science, with 0 publications, and I wasn't sure if I really even mattered. But I had these strong references. I gave a solid and timely job talk, so I guess he took a chance. And it was a chance that I'm glad that he took, obviously, because I rode those coattails. So all of these citations and papers helped me become one of his prominent co-authors. You can see that in this word cloud. And I rode those coattails and I turned them into sales because of Mario's mentorship. And there's 2 lessons that I learned from the risky bet that he took on me. The first is to put your talent in the room where it happens, to quote from a musical. Mario was absolutely amazing, and I cannot stress this enough, about including me in meetings with collaborators. No matter how famous, infamous, how close, how distant the collaborators were, he'd always have me in the room. And within a few years, I went from scientific anonymity to hearing Mario and Pratip as kind of a conjunction that people would utter in the same breath. And sometimes I even got first billing because I got to talk with those collaborators. So it was Pratip and Mario sometimes. And that finally made me feel like I wasn't lost or anonymous anymore. And that really shapes a young person's career. And that's something that I've learned and I try to give back to the community as well. And so I'll never be as good as Mario at that for certain. But I felt like he helped to make me somebody, not an imposter, after feeling that way for 15 plus years in science as a trainee. The second lesson I learned, and that I also still apply today, is a lesson that I running the old lab at NYU, in co-founding terraFlow and leading Talon. I never hired anyone based on their accomplishments. I always hired for the potential to accomplish. And that served me well because instead of having a lab full of minions, I've always been around a team of makers. So the second lesson is to be a maker, to be around makers, and to help make new makers. Sometimes the making can be easy, and sometimes it's just not that easy. In 2004, I did the world's first 18-color flow cytometry experiments, kind of on a whim, honestly. After watching the late Marcel Bruches make quantum dots as a guest researcher in Mario's lab, I got curious, so I did this low-stress experiment one afternoon, just one sample, no big deal. My little experiment worked, and I walked into Mario's office soon after, first making sure that I had analyzed the data from every single possible angle. That's something that I learned from Mario, that you really have to be confident in what you're presenting, even to yourself at the first step. And after a small bit of discussion, in an understated way, he said, "You just did the world's first 18-color experiment, congratulations." And that was a barely planned, but fundamentally sound and careful experiment and that became my first Nature Medicine paper. It was, in some respects, kind of easy. But underlying that was the fact that there were people who made the unprecedented feel easy. Because like Mario, they carefully set up systems for success from reagents to hardware, and that's what paved the way. And so Marcel, who passed away in 2022, was a careful scientist and an incredible mentor and a person who helped to develop these probes that we used for those experiments. In my early days in Mario's lab, Steve DeRosa taught me how to be meticulous and almost obsessive-compulsive about the way that we do these experiments. And Steve Perfetto, who was basically the glue that held that together, he was instrumental in making sure that our instruments could perform in a way that the experiments worked almost automatically. And so it wasn't just that Mario made it so we could do these things. He hired the people who established the foundations in the most rigorous way possible, and they've been amazing mentors to me as well. The data analysis certainly wasn't easy at first. There were no tools to report high-parameter experiments, and so I co-opted shareware software from Family Trees, and this image on the left is from one of my notebooks that I found in the basement. It's probably government property, and Doge is going to come after me, but I basically prototyped this in the notebook, and I co-opted the shareware to show the frequencies and the hierarchies of populations. And then after that lab meeting, Mario didn't say anything, disappeared into his office with the door closed for 2 days. And then when he emerged, he just came to my desk. He said, "Come over, I want to show you something." And that was the development of Spice and Pestle, which blew me away. It was a software that took a junk of an idea that was clumsily executed on my part and built this beautiful visualization. Spice revealed the importance of polyfunctional T cells and also inspired our phenotype to literature mapping software called terraFlow that is actually a booth here at Cyto this year and is one of the companies that I co-founded. So here, many years later, 21 years later, Mario's efforts are still having an impact. This is great mentorship and leadership. It's identifying a bottleneck and then quickly removing that for your team. And Mario was repeatedly kind of a bottleneck disruptor. With Spice and Pestle, that was certainly the case. With an anti-CD27 reagent from Coulter that was the best reagent we had at the time, it was a pain to kind of constantly order it and constantly run out of it. We couldn't get the material to conjugate in-house. So he basically negotiated a way to pay for the pure fraction, but get the discard fractions for which worked just fine for our purposes, where the excess dye and the excess unconjugated antibody were just washed out. And so the staining was still valid, and for our research purposes were great. And it taught me a great lesson that I'm still using in our lean startups about trying to really think through fundamentally the materials that we're using and the protocols that we're using, and making them give us as much as possible from that. Similarly, a lab tech in the lab, Maggie, was really frustrated when the second twin study was on tap, this enormous effort that Thomas is going to talk about today. There were going to be tons of vials that we had to thaw, and I was seriously worried that she was going to quit. She had threatened that. We talked it out in the meeting, and it wasn't about how to make things, how to soothe Maggie's feelings or anything like that. It was about how we were going to get around this fundamental problem that everybody had when they tried to thaw cells. And so Mario invented ThawSome, which is a small adapter to make thawing much easier, and that became my first patent. So I certainly don't have any kind of patent record like Yolanda showed for Mario, but it was thrilling to be a part of that. And in typical Mario fashion, he let me present to the board at the NIH that actually approves these patents, and that was an amazing Shark Tank-like experience for me. And then you heard a little bit about OMIPs. Yolanda and I were frustrated that we weren't getting credit and weren't able to really publish on panel building. So the solution that Mario developed was with us was to come up with a new manuscript type. And so to wrap up then, Mario's influence and legacy is really, to me, quite remarkable and, of course, very, very personal. The Mario-Pratip conjunction, that term helped bring fundamental tools into our ecosystem. My vision is getting worse and worse as I get older. It's awful. We talked a little bit about all the things that Mario has done for the flow cytometry community. You can see those here. But Mario had an impact in an incredibly wide variety of settings, and it's a reason that I still smile now when at Talon I get a client, as I recently got, studying ALS, and not a disease that is immune-related or is typically thought to be immune-related, and not typically something that's investigated by flow cytometry. I start to think that I'm addressing a piece of that legacy of Mario's, where I also have an impact in a small way in settings outside of flow cytometry. And perhaps most importantly, he's the quintessential maker of technology, people, and ideas. He's the kind of leader who made work easier, who makes work easier. And it's really the ultimate way to empower and inspire when you are someone who is making work easier like that. And he's been a resource for spreading systematic, careful, and sound science. So I'm going to leave you with the words to a Foo Fighters song, My Hero, which was released in 1998, and I'm trying to see it. Kudos, My Hero. Oh, God, it's so hard to see. I can see it up here, thank God. Kudos, My Hero, leaving all the best. You're my hero, watch him as he goes. For 14 years, I got to watch my hero up close and personal, being an ordinary guy, making the unprecedented seem easy. And it was really, really a joy. And I can't thank him enough for that. And I can't thank him for really the best times in my scientific career. And so I leave you with this relatively recent, oh shoot, we lost it, there we go. This relatively recent photo, which was taken by Bill Hune yesterday, which sums up the spirit, hopefully, of this important tribute. So thank you, Mario, for everything that you've done for us. I can't tell you enough how much I love you and how amazing my experience with you has been.
So our next speaker is going to be Enrico Lugli. He's a group leader at the Translational Immunology Lab and head of the flow cytometry core facility at Humanitas Research Hospital. He earned his PhD from the University of Modena in Reggio Emilia in Italy under Andrea Cosarizza, and later worked at the NIH with Mario Roederer, where he contributed to pioneering research defining stem-like memory T cells, and with Nicholas Restifo, and advancing IL-15-based immunotherapies with Thomas Waldman. His research explores T cell responses in cancer and the impact of immunosuppressive cells like regulatory T cells.
Okay, thank you very much, Yolanda, for the kind introduction. Thanks also Kathy and Virginia for putting this together. It's a true honor to be here today and telling you how important has been Mario for my career. So actually, I went back had to go back to my records and try to remember when I met Mario. And the first time I met him, I didn't introduce myself, but that's where I met him for the first time. So this is a meeting. I was still a student in Andrea's lab, and Andrea was kind enough to send me to this meeting where Mario was speaking here, was the first speaker. So this was a flow cytometry workshop organized by an Italian society. He was the first speaker, and he was talking about flow cytometry in the 21st century, more colors, more questions, more answers. And so the first time I saw his talk, I said, wow, this is amazing. I want to work for this guy one day. And so I went back home and I started to study, and I fell in love with this manuscript, and I'm sure you know about. So I am an immunologist. I trained as an immunologist, and I thought this was really mind-blowing for me. So this was the characterization of naive cells by using many colors at the same time. And basically the bottom line of this paper was you need many more markers, not just 1 or 2 markers, to define naive cells with precision. And this was using 11 different colors to actually define these naive cells. Otherwise you end up with a lot of contaminants which are not naive cells, they're memory cells by either phenotype or function. And the other paper that I want to mention has been truly important for my career, and I believe has been important also for yours, is actually this one. Spectral compensation for flow cytometry, visualization, artifacts, limitation, and caveats. And so with this paper, we became familiar with a lot of things that we now know about, which is this concept of spread, FMO, so fluorescence -1 controls, and also single stain control for compensation. I read this paper yesterday again, and after 25 years it has been published, I still find new stuff that I didn't know about. So again, if you have the chance, go back and read this paper, because I believe it's a true milestone for us working in the field. So that's when I started to stalk him very much. And I said, okay, so I want to work for that guy. So I started to send emails, making also phone calls. And in the end, I was able to manage, I was able to get a position, and that's where I left my small town in the province of Modena, Campo Galliano, and took a plane. That was January 13, 2008, and I went to Vaccine Research Center. And I was ready to be initiated to incredible science. And I just want to show you some of this incredible science. So this was regular lab meeting. Journal club. And it was very important, it was a relief after you had some paper submission to get, time for some party. Sorry, I pulled this from Keystone Conference we had back in the days. So that's how I talk about true science. So I went to his office and he asked me, what do you want to work on? I said, I want to work on memory T-cell differentiation. I said, okay, we have a collaborator who wants to identify stem-like memory cells in humans. Okay, what are they? Well, we don't know. So at the time, there was a concept that inspired by work from Sallusta, Federica Sallusta, and Antonio Lancevecchia, that suggested that we had heterogeneity in the memory compartment, where central memory cells were the true reservoir of memory. So they were precursors of the effector memory migrating to peripheral tissues. And these central memory cells were self-renewing. But there was also some evidence that actually earlier differentiated memory cells existed, at least in the mouse. Apparently there were some memory cells masqueraded as naive that were behaving as memory. So that's what we started to do. So we discussed some possibilities. I opened the fridge. I had the possibility to use hundreds of different antibodies conjugated to any fluorochrome you can think about. And that's what we started to do. So we started to profile with only 18 colors at the time. It was the only place on the planet where we were able to do to use that kind of technology. So that was the approach, to gate on CD8 cells and then use a number of markers to define naive cells as precise as possible. And this was the Roederer naive approach. So use RO and CCR7, RA and 62L to exclude all the possible memory contaminants, CD27, CD28, IL-7 receptor. And so by profiling, we ended up having a small population of cells that looked discordant by phenotype. So CD95 positive, that generally we think these are memory-like cells. And so we started to study those, and we ended up having a number of different assays to demonstrate that these were memory by function. So these cells were actually naive by a number of markers, but many, many markers, but in the end discordant for one, which is 95. So I owe so much to this plot. Seriously, I can't think about an experiment that was more important than this in my life. So, but obviously the question here was if this was a real population or just some spurious events, okay? Because you have some events there, a shoulder of fluorescence for CD95, not even high fluorescence. So we wanted to demonstrate there was really something. So, and to be honest, I didn't know what to do, but I went to Mario's office and let's ask Mario. So I came up with an idea and said, oh, we should do some. We really have to show that these are different. What do we do? So we should do some gene expression profiling. I said, why? Gene expression. You have 20 colors. You can demonstrate a lot with the technology that we have. We don't waste time in doing gene expression profiling. So I went a bit disappointed back to the lab and said, I'm going to do it anyway. And I did it. Look at this beautiful data. So these cells are the one in red at the top, and they truly cluster separate from naive, also separate from the other memory cells, and these data show that they were different by whole genome expression profiling, so a number of different genes that we can measure simultaneously. But obviously this says, you know, another day, another T-cell subset, we have a lot of heterogeneity in the immune system, and, but we really needed to have a proof that they have peculiar features. Okay, so what do I do now? Okay, let's go to Mario's office. Let's ask Mario once again. And we have the possibility to do an interesting experiment with collaborators. We can modify cells with chimeric antigen receptor and transfer them into immunodeficient mice. Mice? Why would you want to do mice? I mean, no, we don't have the technology. Don't do that. But if you think it's important, well, do it anyway. So I went back to the lab and did it. And look at the fantastic data that we had. So again, so the memory stem cells, once modified and transferred into immunodeficient animals bearing a human tumors, were able to control tumors much better. And this is the survival of the mice. And you can see at the bottom the in vivo imaging for these cells. And actually, the two mice in the TSCN group that you see that died, they actually died not because of the tumor, but because of the potency of these cells that we discovered together. So this paper ended up eventually be published in Nature Medicine. That was really, truly the beginning of I believe, of my career. And that we published it as shared first and last authors with Nick Restif and Luca Gattinone. And this was really the beginning of a plethora of studies that's looked at memory stem cells in different conditions. This is just a selection, but the paper, fortunately, nowadays has been cited 1,000 times. And with a bit of pride, we have extended this recently by showing that there is even more heterogeneity in the immune system. Some of these stem-like memory cells express checkpoints. They're different from the classical conventional stem cells that we discovered 15 years ago. And we redefined the model a bit by showing that you don't have just a trajectory of memory differentiation, but you have many, at least two, and every trajectory bears its own stem-like precursors and terminally differentiated cells. And this initiated in Mario's lab 15 years ago. So in conclusion, I just want to leave you with some thoughts. So what I think, what is my impression of Mario's way to do science. So the first thing is, and I'm really true about, just leave your people free to do whatever they want. Do not micromanage, as he did. And they'll come up with some ideas, if they're smart enough, obviously. The second thing is work hard. So give them a lot of resources if you have them, a lot of possibilities. Let them work hard. But obviously the most important thing is also party harder. That's also important. You need to have fun. We've always had fun in the lab. It was not just a work. It has been always a passion. Fourth thing, foster collaboration. Every project was never a one standalone thing. It was always a collaboration with other people. People within the lab, people outside the lab, within NIH, outside the NIH. And I'm truly grateful for that because I was able to work with the most beautiful minds on campus and outside campus. And last thing, push technology. The lab has always been an origin of the most beautiful technologies. We mentioned flow cytometry many times, but we also optimized at the time single-cell qPCR, which ended up being in a JCI paper that we published. This was the group back in 2011. There's a lot of people that I also want to thank. Mario was able to put together a group of people, truly fantastic people, Pratip, Kathy, Yolanda, Steve Perfetto, and everybody else. And I just want to leave you with this image, which is in my heart very much. He honored me to be at my wedding a few years ago. He came with his polychromatic tie. So thank you very much. We love you all, and thanks a lot for being here.
Okay, our last speaker today is Bob Balderas. Bob has over 45 years of leadership experience in both academia and biotechnology, with specialized expertise in immunology and flow cytometry. He has played key roles in product development, scientific collaborations, and business strategy at Pharmagen and BD Biosciences. Notably, Bob worked closely with Mario at the Vaccine Research Center since its inception, providing innovative support in both instruments and reagents. Many of these collaborations led to groundbreaking scientific discoveries and the development of new products.
Thank you very much. And you know, it's a very special time to be able to reflect and just hear these stories, because just imagine how many there really are. You know, just about a week ago, I took a few moments, and because I save every email I've ever had, or you can imagine when you go back to the 80s and those. And I searched on Mario, and then I went over to my iMessage, and I looked up Mario. And then I thought to myself, oh my God, I have wasted so much of his time. You know. And then I started to do the math, and then I thought, if I ask that many questions, imagine how many other people ask that many questions too. So I have no idea how he answered them all, but it is a journey, and it's certainly a celebration. You know, the program that I put together here was originally one that was very personal from myself to Mario. And then I read it through, and I practiced it, and then I walked backwards for a moment, and I thought, you know, there's another story here about teams. And I thought it might be really good to share this one story. Now, when I first came into Frank Dixon's labs in the 70s, a big announcement was made, and that was that we had signed an agreement with Sandoz for millions of dollars that came into Scripps. And then about 15 years later, we signed another agreement with J&J, and for even way more millions of dollars. And then after 20 years when I left, he said to me, make sure that there's always a connection between what an academic does or what you do in government and industry, because there's a tremendous value there. You have to be careful with it, but if you ever find the opportunity, you know, look at it hard. So this is that story about that part. So there's lots of memories and moments and defining moments that we all have with Mario. And if I had asked everybody in this audience to stand up if you've had one of those, then you know what I mean. And if you've never had the opportunity to talk to Mario or to ask a question, then you need to do it, right? Because if you think about the definition of radical candor, Mario lays it on the line and helps us through lots of different kinds of questions. So I look at Mario from lots of different perspectives. As a biologist, and mainly I think that's where you wanted to be, right? As a mentor to so many, as an innovator on so many things that was shared earlier. I think one thing really important is as a father. And we had a few of those conversations over time because it's about, what our children do that helps define us. And that was some of the words that he shared with me a long time ago. But also, he's a domain leader in our field, as we all know, and a friend and a colleague and a visionary for everything that this field stands for, both in the biology side as well as technology. Now, the last one I put there was a team builder because, when individuals that have so many different types of, good things about them, there's also one in there that exemplifies, the 4 people that sit, or 5 people that sit on this, in this program, because it's about how you bring those people into your group and then how you inspire them to let them do the best things that you can ever imagine. So my story, and the story that I'm going to share, is one that starts in Stanford. It went to Farmington. It went over to NIH. There's a FlowJo story inside. And then all of a sudden there's BD, kind of all mixed up in lots of different ways, and lots of stories and lots of really great memories. But then it ends over here with industry and government, okay, with a CRADA. So before I put the CRADA up there, just have to say this, that Mario was able to put a CRADA together for a very specific purpose that only took a few weeks at the NIH and took BD 7 months to sign it. So who would imagine that the government could work a lot faster than a company? So the CRADA was an interesting CRADA, and it tells a story of a time when there was a paper that Gary Nolan, myself, and his team put together and published in Science about Cytoph, and it disrupted us in this field of flow. It disrupted us, and it took us, when we were only about 18 colors, all the way up to 34 lanthanides, and it gave the world a chance to look inside the cell in a different way. Right or wrong, the technology was out there. So this story is about this CRADA. This CRADA was put together from both NIAID and BD to establish some best principles, to develop some technologies, but more importantly, it has to go 2 ways, right, on a CRADA. One was to make sure that everything that got done answered questions at the VRC and areas for which were really important for Mario and his program. Not so much on the product side, because it was about development and how we shared and how we put that together. But Mario allowed that to go through. And as we did, there was a team that was formed. Now, the team on the BD side was long, and there are a number of individuals that were not on the team the whole time, but contributed so much in that. It was a lot of the SORT team in BD. But for Julie, who's here, for Pratip, for Steve that's sitting down below, and also Richard and David, who unfortunately couldn't come here today for some personal reasons that were all good about their families. That was a very special team. They were allowed to do what they do best and unencumbered. And they worked with our team for years, for a long, long time. But the reminder in this team, and a reminder of everything that we did, was that we had a meeting every 3rd Thursday of the month for many, many years. The story that goes along that, it wasn't about just a few minutes that we spent together, and it wasn't about days that we spent together, and it wasn't about weeks, and it wasn't about months, it was about years. And when you put all those together, there was a development of a platform technology for which we embedded a interesting instrument that had not DIVA electronics, but had a GMS electronics platform on it. But we were looking to see how it could really be, established as a platform for discovering, and to take us up to a place where there was higher dimensional flow. But there was one person in that group that Mario had empowered to do many things, and that was Steve. So if I look back over all these years of development and the 200 plus times that we met as a team, there was a series of notes that tell a story that is so perfect that you can dot the I of virtually every single decision that was ever made. And Steve put those together, and I just like clipped out just a few minutes out of one of them because there's about 20 pages for each one. I have no idea how he did it. But I know one thing, in a company I've never ever seen that. But it established a way that we work together. And Mario was always there to help ground us with these words that were said over and over again. It was, BD, you need to not be so excited about higher dimensional flow, because not very many people might be doing that. But what we're really establishing right now is an instrument that has boundaries that are bigger than the boundaries of an 18 color instrument, that gives everyone a chance at 10 colors, at 12, at 14, at 15, or 16, a chance to make a panel better. And I think he was right after all these years. And it was just something that grounded us all the time. And that started with this prototype of what Larry Duckett called the X50, because he liked space. But it was a time where we embedded an instrument in a team, a time when there was countless interactions that Mario allowed between his team for interactions, because our team could not be at NIH all the time, but what they had to do to make adjustments in the instrument or whatever was needed. Richard this morning reminded me of all of those kinds of interactions that he said he had with Austin Wu and with David and with Larry. But it was implanted inside that room to be able to be an experimental instrument. And it became that. It became an instrument that started to bring us information that we never thought was ever possible, but we were being guided with great science to be able to do this work. At the same time, these new colors were coming in from Brent Gaylord and his team at Sirigen, and they also were reshaping lots of the decisions we had. And you know, for a lot of individuals in this world, we actually were building instruments that had 5 1-watt lasers, believe it or not. And maybe we learned later we didn't need to have that, but we sure built an instrument that had to be shut. You almost have to shut down a business to open up the hood. But it was an instrument that had a lot of complications, and the decagons that were there, and in every single step of the way, that team and Mario helped us make decisions. So those decisions just kept going forward, and the instrument got bigger and made changes, and sub-assemblies were changed, and everything got put together, and even the old PMTs were the things that we used in this instrument. And I do remember the time where we had to go and PMT match, I should say Steve and team PMT matched 5 or 6 instruments on one given week. And this all goes into a greater, day, a day for which we actually got together, because all of a sudden we had an instrument called a symphony. Now this day happened in BD, and it became a day where we showed Mario what the instrument looked like. We had decisions on color, we had decisions on what it looked like at the front. So Mario right here is looking at an instrument, the first one that was made for the VRC, because I think there was maybe 5, 6, or 7 instruments that came into it. And then we turned the instrument on, and then there was kind of something there for him. And Larry and his team had embedded something special, a little bit of bling, to make sure that everyone could see all the laser lines that were on at one given time. Now, that was not set up for every instrument, and we did ask Larry at the moment, like, how much did it cost him to do this for this one instrument? I should not say how much it cost, but it was unaccounted for dollars. But at the very end of the day, we had an instrument that began to change a lot of things in this world. One for which Larry and Mario, 2 pioneers in what they did, because it took the LSR2 days that Mario 2 was important in there, all the way to an instrument platform that could do 50 PMTs, 28 dimensions of flow at the time. And we celebrated that with Claude D'Artiglione, our president at the time, and everybody that was contributing to hopefully, make this a big success. I close this, though, with another friend, a friend that wanted to also say hi today. One that Mario worked with for many, many years in the Stanford lab. Ellen Stahl was always one that always, looked up to Mario and all the contributions. And, when you have an individual who gives you the grounding that you need, whether you're in a personal perspective or in a company, or one when you're actually working in the lab with them, then you learn a lot of things. These types of outputs, even the posters, were important. Mario empowered this team to build these, right? And to use our technologies that were not ready for prime time, but to establish, good standards in everything that we do all the time. So I thought I would finish with something, because I was on this morning at 6:15. I know it exactly because Richard sent me an email at 6:15 in the morning saying, "Bob, I'm sorry, he can't be there." But I was looking through the Purdue, and I went way, way back, and I pulled one up in 1995. So 30 years ago, and it was a reminder. It was something that Mario put out there, and he said, there's 3 things important in standardization, right? There's always a reason behind these. And he said that they are standardization of the instrument, proper compensation, and then he had this other one, which was saturating antibody reagents. And he was just giving us some words. So it says, we set up a single set of reagents to cover the entire study. Also, they were carefully titered under the staining conditions that were used. And he goes on to say the importance of it, of saturation. And then I got this, when I saw Richard's, comment that came across. I hadn't read everything. But when I got off the phone with him this morning, I read the rest of his comment. And it says, attaining saturating reagents is difficult for many PE reagents and most Sci5 PE reagents, since virtually all manufacturers bottle these reagents much too dilute. And yes, I have tested many manufacturers' reagents. Please, salesman, don't email me to tell me that you sell saturated reagents. And I thought it was just apropos that there's always insightfulness, there's always correctnness, truthfulness in all of those moments that are defining for all of us when we were able to, work with Mario. So Mario, I thank you very much for everything in guiding us to a place where today we do have higher dimensional flow with lots of new kinds of technologies, but it did start with the one that you helped us build. I thank you very much.
Thank you, everyone. I mean, we can just keep going, telling stories about the wonderful time in Mario's lab, what we learned, what we did. Maybe tonight we can talk more about it. But I'm sure, Mario, everybody who's here assembled today is joining me in wishing you a beautiful future, whatever it will bring, whether you're going to travel the seas or keep enlightening everybody about all things flow cytometry. It's probably going to be a combination of both, I'm feeling. But thank you for everything that you have done, that you're still doing, and especially for the kind and intelligent, inquisitive, and fun human that you are. Kristen Beers really summed it up very beautifully. She said, "You've been so much more than a boss. You've been an extraordinary mentor, a role model, and a guiding force for everyone who passed through your lab over the years. Your leadership didn't just inspire excellent work, it fostered personal and professional growth in all of us. Thank you for your unwavering support, your wisdom, and your kindness."